Hello students, welcome to compiler design class. In today's lecture, we are going to discuss about introduction to compiler design. So these are the set of topics which we are going to cover into today's session. At first, we are going to see what is compiler. Next, we are going to discuss what are the features of compiler. Then next, types of compiler. Then next, tasks of compiler. Then next step of language processing system. And at last, we are going to discuss the today's summary of today's lecture. So what is compiler? So compiler is a program. So first of all, compiler is a program. That means it is software part. So that means compiler belongs to software part, not a hardware part. So compiler is a program that reads a program written in one language and translate the equivalent program in another language. Written in one language and translate it into another language. So first of all, compiler is the program. So what that means, compiler belongs under software category. And now question arises that compiler, which type of software? So obviously it is utility type of software. Okay. So all of you already know that software can be categorized into utility software. Some software are categorized as a application software. So compiler belongs into utility software. Why? Because compiler basically helps us to operate the system, to operate our system. System means the hardware part or the operating system smoothly. Okay, and compiler basically act as a translator. Okay. And what is the task of compiler? To convert one language into another language. So what is the meaning of one language and another language? Here, one language basically defines the high-level language, and the another language basically defines here the machine-level language. So that means whatever instruction we are written in high-level language, like English language. So that set of instructions are converted into machine level language by the help of compiler. So this is the main task of compiler. Okay. So if you see, this is the pictorial representation of compiler. So in that case, compiler takes input the high level language. That means whatever instruction we have written in English-like language and converts it into the low-level language as the output. That means the machine level language, so that the machine can handle the instructions whatever is given by the user. And during this conversion, if any kind of error is occurred, and also those errors are properly handled by the compiler. Okay, so this is the overview. This is the very brief overview of compiler. So now question arises that if there is some software we need to use to convert the instruction whatever is given by high level language from the user end to the low level language. So then why we are not directly giving the instruction into low level language? Because as a human being, it's very tough to give the instructions in low level language, because the low level language or machine level language basically consists of 0, 1. Okay, basically consists of 0 and 1. That means in binary format. That means in binary format. So it's very tough to give the instructions in binary format as a human being. For that reason, we are going to use high level language, just like English language, and write all the instructions whatever the user want to interact with the system. And compiler is the responsible software, utility type software, who basically converts those instructions from high level language to low level language. Okay, or it's better to say in machine level language. So this is the concept of compiler, very brief concept of compiler. But that task means the conversion from high level language to low level language are not occurred in the same phase. Nowadays, many of the compiler basically follows two steps during conversion of this high level language to low level language or machine level language. The first phase is called the analysis phase. And the second phase is called synthesis phase. So most of the compiler follows basically follows these two steps during the conversion of from high level language to low level language. So in the first phase, the source program is compiled. Source program means the instruction, whatever is written in high level language. So that particular source program is compiled and translated into an object program, which is sometimes called intermediate representation. That object program may be represented in a low level language, or sometimes it may be represented in as a assembly level language. Okay. So that intermediate representation again take as the input in the synthesis phase, and synthesis phase ultimately converts it into a bare machine level code. That means executable code. That means executable code. Okay. So this is the pictorial representation of this two phase. So at the first phase, that means in the analysis phase, the source program, that means the program which is written in high level language, that particular program takes as the input to the compiler and generate the object program or the intermediate representation, which is represented normally in through assembly level language. And that particular representation or object program is again take input as into the assembler, and assembler ultimately generate the executable code. Okay, or the bare machine level code. So this is the phase which nowadays most of the compiler follows. Okay. So next, what are the steps for language processing system? So these are the steps which basically includes, into our system during the process of conversion from high level language to low level language. So at first, there is the source code. The source code means the set of operations which is written in high level language by the user. That particular source code is given to the system as the input, and that particular high level language at first will be handled by the preprocessor. So what is preprocessor? Preprocessor basically helps us to remove all kind of directive. Directive means, if we take example of C, so all of we already know that whenever we are going to write any program using C programming languages, what we need to do? At first, we need to include some library file like stdio.h. stdio.h, or what we are going to do? We are going to include some hash define. So these set of instructions are called, these set of instructions are basically handled by preprocessor. These set of instructions are called pre-directive. Okay. So at first, whenever we are going to input the instructions in pure high level language, so preprocessor is basically responsible to take care of this kind of the directives. And what preprocessor do? Preprocessor simply remove those directives and convert the pure high level language into normal high level language. Normal high level language means in that particular piece of code, no such kind of directives that exist. It simply replaces all the instructions whichever is instructed by hash include or hash defined symbol, or and convert them in the pure high level language. Okay. And that particular pure high level language is basically takes as an input to the compiler. Okay. And then compiler converts the pure high level language into an assembly level code language. And then that particular assembly level code language is take input as the input to the assembler, and assembler creates a relocatable machine code which normally written in assembly level language. Sorry. Which basically written in assembly language. So assembly language is basically combines of high level language and low level language. Okay. So compiler Basically. So what are those states? So at first the pure, at first the high level language takes as the input to the system. Then preprocessor converts the high level language to pure high level language by removing all the by or removing all kind of directives like hash include or hash define. If we take example C language, then compiler takes input those pure high level language and convert and generate assembly level assembly code. Okay, and assembler uh, assembler takes the assembly code and generate a relocatable machine code. And whatever assembly code, that particular language is basically written in normally in assembly level language. So assembly level language is a combination of high level language and low level language. Now next, what will be happen? Those set of relocatable machine code is basically handled by linker and loader, and ultimately linker and loader creates a absolute machine code, machine level code. So what is the difference between relocatable machine code and absolute machine code? The relocatable machine code is a machine code which is basically capable to execute from anywhere in our primary memory. Okay, and absolute machine code is basically a code whenever those relatable machine code is actually going to assign some particular memory location for execution. Okay, so these are the set of steps which actually follows whenever we are going to convert any instruction whichever given by high level language to generate a executable machine code. But into this course, we only going to discuss about the compiler only. So that means whenever we are going to talk about GCC compiler, suppose we are going to talk about GCC compiler. So in that case, GCC compiler contains all these set of steps. Okay, it contains the preprocessor, it will contain the compiler, it will contain assembler, it will contain linker, loader, and ultimately by combining all of these operations, it will execute the executable code or whatever you say. Suppose Java compiler. So Java compiler also contains all these set of instructions by set of steps by together and ultimately code a executable machine code. But in these sessions, we are not going to discuss or we're not going to discuss the other steps like preprocessor, assembler, linker, or loader. We only going to discuss the compiler elaborately. Okay, so that means what are the steps of compiler have and what are the steps of error detection or error removing process compiler have, how compiler able to generate parse tree from our high level language. So all these are things we are going to discuss into this lecture. Okay. So next, what are the features of compiler? Obviously, correctness, speed of compilation, preserve the correct meaning of the code, good error reporting or handling, and the last one is code debugging help. So these are the set of important features of any compiler. So that means whenever we are going to compile any particular code which is written in high level language, so obviously that particular set of instructions must be converted into equivalent machine level code correctly. And obviously the speed of compilation should not take very much time. And obviously it must preserve the actual meaning. It must preserve the actual meaning during the time of conversion. During the time of conversion, if any kind of error happens, obviously the compiler is the responsible to report or to handle those set of errors so that the erroneous code must be corrected must be corrected by the user. Okay, and obviously the code debugging help. So this is the set of features which must include in any compiler. Okay, any compiler software. So what are the types of compiler? So depending on the type of the traversal of our source code, traversal means the traversal of our source code, the compiler can be categorized into three ways. One is called single pass compiler, another set of compiler is called two pass compiler, and another set of compiler is called multi-pass compiler. So depending on the type of the traversal, compiler can be categorized into these three ways. So now let's see what is single pass compiler. So in single pass compiler, generally what will be happen? The compiler will traverse our source code, that means which were written in high level language only once. Okay, and produce the object code. So just by traversing the source code only once, if any compiler able to generate the corresponding object code, then those set of compiler is called single pass compiler. So here in this picture, we can see that there is one part which is called scanner, takes the high level program, high level instructions, high level language as the input. And with the help of parser is another part which basically helps us to generate the parts tree, to generate the parts tree by seeing the high level language. So what is parts tree? Parts tree is nothing like nothing like a tree like representation of our of the rule of any particular language. So how can we able to generate the parts tree? We will see into the later into our lecture series. Don't worry. Okay. So at that moment, we just concentrate on that how single pass compiler works. So single pass compiler is a type of compiler which basically takes the input which is written in high level language and generates the corresponding object code just by traversing a single time. So in early days, Pascal compiler follow this type of notation. Okay, but nowadays most of the compiler follows the two-pass compiler or multi-pass compiler. So what is two-pass compiler? So instead of traversing the source program only once, what is happened? The compiler just break their work. What means break their transformation work from high level language to low level language into two parts. In the first pass, which is sometimes called front end or front end part of our compiler, is basically part from the analytical part. Okay, analytical part means in that case the compiler only generate the platform dependent intermediated code. Okay, how it going to generate? By following this set of steps. Okay, so at first compiler scan the input whichever is written in high level language. Then from that the input it generates the corresponding. It will try to find out the corresponding uh, syntax whichever is written into our programming language is correct or not. Correct or not means whatever that particular syntax is matched to the grammar rule or not, grammar rule which is already defined to that particular language or not. After that, the compiler try to analyze that whatever instruction written into high level language is meaningful or not. Okay, so by analyzing those all parts, it will generate a intermediate representation or intermediate code which is platform independent. So this part is called analytical part or analysis part. So this is the first phase of any compiler. And for performing this particular first phase, this set of steps must be incorporated. So lexical analyzer phase, syntax analyzer phase, semantic analyzer phase, intermediate code generator phase. So this set of phase must be incorporated for successfully completed the first one. Okay, and now what is the exact role of lexical analyzer, syntax analyzer, semantic analyzer, or intermediate code generator? We will see. Don't worry. Into our course, into our subsequent next lecture, we will see. We will discuss. Okay. So, but now we just need to know that how two-pass compiler actually works. So, in two-pass compiler, in the first phase, what will be happening? From the source code, it will only it just simply traverse the code word the source code which is written in high level language and generates a platform independent machine code. Intermediate, which is platform independent, not machine code. It's better to say platform independent low level code. Okay, and this phase is called analysis phase, and this analysis phase contains this set of instruction contains this set of tools or this set of instructions. Suppose lexical analyzer, syntax analyzer, semantic analyzer, and intermediate code generator. And after generating the intermediate code, which is platform independent, what will be happen? That particular intermediate code, intermediate representation or platform dependent mission low level code is takes input as a second phase. Okay, and the second phase is also sometimes called the backend of the compiler, and it is the synthesis phase. That means from that particular platform independent machine level code, what will be happening? The synthesis part is actually going to create a machine level code which will be executed into that particular machine. So obviously that particular machine code is a platform dependent code. Okay, platform dependent means the hardware dependent code. And for creating that particular platform dependent code, what we need to, what are the set of tools which basically helps us? The first one is the code optimization and the second one is the code generator. Okay, so the two-pass compiler. So nowadays, most of the compiler follows the two-pass compiler. So two-pass compiler basically follows these two steps. At the first phase or the first pass, what will be happening? It will take the language, whichever is written in a high-level language, and convert and analysis that particular source program. Analysis it means analysis by syntactical analysis it by semantical, and after that it will generate a platform independent low-level language, okay, which is sometimes called intermediate representation, okay, and after that, that particular platform dependent machine level language, low level language is takes as an input to the second phase of the compiler, which is called synthesis part. and into that particular synthesis part, what will be happen? The actual machine dependent or platform dependent executable code is generated. So this is the concept of two-pass compiler. Now, multi-pass compiler. So in that case, what will be happen? In multi-pass compiler, process the source code or syntax tree of the program several times. So in case of two-pass compiler, what will be happen? It will just sorry, it will just traverse the source code only twice. But in case of multi-pass compiler, what will be happen? It will traverse the source code multiple times to generate the ultimate machine level code, machine level executable code from the high level code. Okay, so in that case, the multi-pass compiler has several tiers. The first one is called front end, the middle one is called middle end, and the back end, and the last one is called the back end. Okay. So what is the task of a compiler? So so this is the list of the tasks of any particular compiler. So that means any particular compiler must perform those set of operations. So first one is breaks up the source program into pieces and impose grammatical structure on them. So that means whenever a compiler takes any source program which is written in high level language as the input, at first obviously they need to check that whether the instruction whatever is given into that particular program is follow the grammatical structure of that particular language or not. Okay. Next, allows you to construct the desired target program from the intermediate representation and also create the symbol table. Obviously, you are going to see that now we're going to see that whenever we are going to convert the executable machine code, so at the middle level, at the middle level, it will generate a platform independent low level language code. Okay. So in that case, in that particular process during the conversion from high level language to machine independent machine independent low level language, obviously we need to maintain some table where we are going to store the instructions. What kind of instructions? Instructions like suppose we have write int a equals to 5 into our program. So this is one instruction which is written in the into a high level language, and it says that we are going to declare here one variable named a. The type of the variable is integer, and we are going to assign their value 5. So whenever the compiler tries to create the machine independent intermediate representation of that particular code, so how it will map it? It will say that yes, there is one identifier. The name of identifier is A. The type of the identifier is integer, and the value of that particular identifier is 5, which is assigned by the user. So this type of instruction must be set into a symbol table for future reference. Okay. The third one, compiles source code and detects error in it. Obviously, the compiler is the main responsible for detecting that whether there is any kind of syntactical or semantical error exists or not. Manage storage for all variables and codes. Read, analyze the entire program and translate into semantically equivalent. Semantically means meaningful. So that means whenever compiler goes to convert any high-level language to low-level language, so not only compiler goes to check that whether that particular instruction is grammatically correct or not, also they check that whether that particular set of instruction is meaningful or not. Meaningful means, suppose if anyone writes here, uh, suppose a equals to 5, okay, then they write int b equals to a divided by 0. So now these two set of instructions are syntactically correct. That means they are grammatically correct. Why? Because as per the rules of C programming languages, whenever whenever we are going to use any particular variable, we need to declare it along with the data type. So we do it. We need to assign some value into that particular value. We also do it. But whenever we are going to perform that particular uh, uh, division operations, that particular division operation is also syntactically correct. Why? Because we all know that the division operation is the binary operator. So that means it needs two different operands. So we are going to define here two different operands. One is a and one is 0. So this is also grammatically correct or syntactically correct, but this is not a meaningful. Why? Because we are not able to divide any particular number by 0. So obviously this is not a meaningful. So this type of error is handled by compiler. Okay. Or if we take another very small example, suppose if we write int 5 equals to a. So this is syntactically correct. So here we are going to define one variable named 5 and assign 5 and assign a into the 5. So this is syntactically correct, but this is not a meaningful. Why? Because 5 is not a variable. It's a constant value. And we are not able to assign any variable inside to the constant value. So this is not a meaningful. Though it is syntactically correct, the syntax is correct. We define here the data type correctly. We define here the variable, I mean, the user assume that the variable name is 5. Then again, they properly place the assignment operator. Then they properly place the assigned value. But this is not a meaningful. Why? Because in case of C programming language or any other programming languages, that particular A variable will be treated as a variable. That particular A will be treated as a variable, and the 5 value will be treated as a constant value. So this cannot be happen. So this is not a meaningful. So this type of error is also handled by the compiler. And the last one is translating the source code into the object code depending upon the type of the machine. Obviously, whenever compiler going to translate from high level language to low level language or source level language, obviously that particular source executable code or machine level language must be hardware dependent. Okay, so this is the set of task which every compiler must follow. So summary of today's lecture. So at first, compiler is a computer program which helps you to transform source code written in a high-level language into a low-level machine language. The next one, correctness, speed of compilation, preserve the correct meaning of the code are some important features of compiler design. The third one is compiler divided into three parts according to the nature of compiler, how they traverse our source code. The first one is such a single pass compiler. The second one is two pass compiler, and the third one is multi-pass compiler. Point D, steps for language processing system are preprocessor, interpreter, assembler, linker, and loader. So that means along compiler software not able to do translate from source program to the executable machine code. They also need to take help that those set of other softwares. Okay, and the last one is the main task of the compiler is to verify the entire program, so there are no syntax or semantic errors. So this is our for today's lecture summary. Thank you for your participation. So in next lecture, we are going to discuss about the various phases of compiler design.